Today, we're going to peel back the layers of history to uncover a scientific revolution that you probably didn't learn about in school. We're talking about how ancient Indian scholars were, well, literally calculating the cosmos and laying the groundwork for our digital world long before the names we're all familiar with. All right, let's dive right in.
Just think about that for a second. The binary code, the ones and zeros that run our entire modern world, has its roots in ancient India. While a lot of Europe was in what we call the Dark Ages, thinkers on the subcontinent weren't just holding on to old knowledge. They were creating entirely new ways of understanding the universe, from the infinitely small to the infinitely large.
And it all kicks off with one of the most powerful and maybe profound ideas in all of human history, the idea of nothing. But this was a very, very special kind of nothing.
So here's the key distinction. Other civilizations, yeah, they had ways to show a blank space, a placeholder. But the Indian concept of shunya was totally revolutionary. It treated zero not just as an absence, but as a number in its own right, with its own properties and rules. That was a massive philosophical and mathematical leap, and honestly, it changed everything.
And this leap, it was driven by some absolutely brilliant minds. First, you've got Aryabhata, a true pioneer who gave us an incredibly accurate approximation for pi. But then came Brahmagupta. He's the one who took the concept of shunya and basically wrote the rulebook for it. He's the guy who made zero a real, functional part of mathematics.
It looks so simple, right? Any number minus itself is zero. But this little equation is one of the most important in history. By making it official, by formalizing this rule, Brahmagupta gave mathematics the tool it desperately needed to start solving for unknown variables. So here's the thing. Without this rule, algebra as we know it, well, it just wouldn't exist.
And this powerful new math wasn't just some abstract game. Its first and maybe most spectacular use was in looking at the sky. And that brings us to the incredible field of astronomy.
This really shows the huge shift from superstition to science. So instead of relying on myths about, demons swallowing the sun, these astronomers were using geometry and trigonometry, you could call it shadow math, to predict eclipses. And they weren't just guessing. They were calculating the exact alignment of the Earth, the Moon, and the Sun with an accuracy that is just, wow, it's astonishing.
And the big reveals didn't stop there. Get this, over 1,000 years before Copernicus, Aryabhata proposed this absolutely radical idea. He correctly argued that the stars moving across the night sky wasn't because the heavens were spinning, but because the Earth itself was rotating on its own axis. I mean, what a monumental insight! It challenged the accepted wisdom of the entire world at the time.
Just look at this number for a second. This is the calculation for the length of a year, the time it takes for the Earth to orbit the Sun relative to the stars, and it comes from an ancient text called the Surya Siddhanta. It is an incredibly specific figure.
And here's the punchline. That ancient calculation is only 1.4 seconds different from the value we use today, a value we got using atomic clocks and satellites. It is a level of precision that's almost unbelievable, and it was achieved with a naked eye and some brilliant, brilliant math.
Okay, so now we get to what might just be the most surprising part of this whole story. Most of us, right? We were taught that calculus was the great invention of Isaac Newton and Gottfried Leibniz back in the 17th century. But what if that story started much, much earlier?
Just look at this timeline, a full 300 years. 3 centuries before Newton and Leibniz, a mathematician named Madhavan of Sangagrama, working in what we now call Kerala, was developing some of the absolute core components of calculus. He was working with the infinite.
Madhavan and the mathematicians who followed him at the Kerala school, they discovered things like infinite series for functions like sine and cosine. Now, these aren't just obscure formulas. This is the mathematical bedrock of modern engineering, of physics, of signal processing. The tools you need to calculate wave patterns and planetary orbits were being forged in India centuries before they were rediscovered in Europe.
So you have to ask, right? How did all this knowledge, from zero all the way to calculus, make its way across the world? Because it wasn't developed in a vacuum. It traveled, it was transformed, and it really became a gift to the entire world.
This is basically the pathway it took. The concepts start in India, then they travel along trade routes to the great intellectual centers of the Arab world, like Baghdad's amazing House of Wisdom. There, these ideas were studied, translated, and built upon before they eventually made their way into Europe, where they helped fuel the Renaissance and the scientific revolution.
And if you need any more proof, just look at the numbers you use every single day. We call them Arabic numerals, right? But the Arab scholars themselves, they called them Hindisit, which means from Hind or from India. They openly gave credit where credit was due. This wasn't just local knowledge, it became the global foundation for our digital age.
It really makes you wonder, doesn't it? Learning about the Kerala school, or the true origin of zero, it just proves that the history of science is so much richer and more global than we often assume. And it leaves us with this final, really tantalizing question to think about.
Thank you so much for joining us on this journey here at Veda Vyasa Academy. If you found this trip through time as fascinating as we did, please do us a favor and hit that like button and subscribe for more deep dives into the lost and hidden chapters of our shared history.